In this lesson, then, we'll summarize how natural selection can help us understand some of those original puzzles that we presented at the beginning of the evolution unit. For example, adaptations. What accounts for adaptations, those parts with purposes that we find in nature? Well, for Darwin, it's going to be natural selection. What about the origin of new species? How is it that one species can split into two species? Again, for Darwin, natural selection is an important part of the answer. What about extinction? Why do species go extinct? Again, we can understand that within the concept of natural selection. And classification. Why do species have that groupishness? Again, natural selection is part of the answer. So let's take the appearance of design, the adaptations that we see. And let's look at our stick insect example. Now remember, Paley would have said that God designed stick insects to have that thin body for the purpose of camouflage. Right? So God was the intelligent mind that designed the stick-like body and then created this species, and the species had never changed. Darwin's going to argue that that's incorrect, that while these insects look like they were designed, that's an illusion. In reality, the stick insects had a long history, a long evolutionary history, a natural history that involved ancestors that were not stick-like. In other words, the stick body here is an adaptation that evolved over time. It's just that we don't see all of those previous generations today. We're just left with the fantastically camouflaged stick insects. What we don't see are all those past failed experiments, as it were. We can think of reproduction as producing experiments. So the variations each generation we can think of as sort of experiments through reproduction. And lots of these experiments will fail because these ones down here will be food for predators, leaving the thinnest bodied insects to reproduce and pass on that useful trait. So for Darwin, natural selection explains adaptations because natural selection produces adaptations. It's favoring those useful traits that we call adaptations. What about species origin and diversity? Well, natural selection favors different traits in different environments. So again, with our stick insects, the ancestors did not look like sticks. Well, what if some of them migrated, moved into a new environment with sticks? Now there's going to be a different set of selection factors here, because now it matters what your body shape is. See, because any individual with a slightly thinner body will have better camouflage, and that'll be harder for predators to see it and so eat it. As a result, then, there will be a selection for thinner and thinner bodies in this environment, but not in the old environment. So as a consequence, different traits will evolve in these two populations. If they remain separated, then over time they can become separate species. Well, that might explain how one species can split into two species, where some members go into a new environment and some stay in the old environment. What about just the incredible number, the incredible diversity of species? Well, here we just have to add to this story the fact that animals and plants are constantly on the move, right? There are constant changes in environments as animals migrate and colonize new places, and plants colonize new places, and new species enter and leave environments, new diseases emerge, etc. There's constant change, and there are many different ways then to sort of make a living in these complex ecosystems. And so natural selection will just tend to favor whatever traits will be best fit to whatever the current local circumstances are in the environment. And because there are so many different places to live and ways to make a living, natural selection has generated a lot of diversity in species. Now, what about the groupishness of species? Well, here Darwin's going to argue that species with recent common ancestors are more similar. Right, because there hasn't been much time for differences to evolve. And so that fact then is why we can put the species into categories based on similarities. So for example, in our evolutionary tree down here we have the common ancestor of all 9 currently existing species. But species 1, 2, and 3 share lots of similarities. Why are they so similar? Darwin would say because they have a recent common ancestor. Species 4, 5, and 6 are also very similar to each other. Why? Because they too have a recent common ancestor. And likewise with 7, 8, and 9. But we can now think about how the three groups show differences in how similar they are to each other. So in other words, at the group level, GX is more similar to GY than GX is to GZ, because GX and GY have a more recent common ancestor than GX and GZ. That common ancestor was farther back in time. And so when species have more recent common ancestors, there's less time for differences to accumulate in the species, for less time for changes to evolve, for new traits to evolve. And so that's why we can group species 1, 2, and 3, put them in a group, and then we can group GX and GY into a group, and then we could group all three of these into a group, and we had of other species over here. So species are groupish, or they possess groupishness because of their evolutionary history, because of this idea of common ancestors splitting off into multiple species, and the amount of time that has elapsed since the common ancestor determines sort of how similar species will be. And finally, what about the extinction question? Why disappearance of species? Well, to offer a simple example here, of course we know that the dinosaurs and many other species went extinct when a big asteroid hit the Earth some 65 million years ago. So clearly that's going to be tough for natural selection to equip creatures with such a dramatic change as that. But that's the idea, that extinction is the result of the fact that in many cases in the history of life on Earth, environments are changing too fast for natural selection to generate adaptations. And these changes could be brought upon by, yes, an asteroid collision, or plate tectonics, continents moving around, and climate changes, and the Earth cooling and warming, all kinds of things. And of course, the evolution of new species, evolution of new predators or new prey or new parasites and diseases, these all can cause changes in survival for the currently existing species. So because there's a lot of change happening in the biological world, not only new living things are evolving, new species are evolving, but also the physical planet is changing. You get lots of changes that can influence the success of species. And many species have gone extinct because they were unable to evolve adaptations for whatever change was happening. So let's do a final comparison of Darwin versus Paley with respect to our four ideas here: adaptations, diversity, groupishness, and extinction, these four sort of puzzles that we began with. Adaptations. Darwin's going to say that natural selection is causing adaptations to evolve. For Paley, this is referring to God's intelligence then. God was the intelligent designer and made those parts with purposes. For the origin of species and the diversity of species, Darwin's going to argue that the separation of one species into two environments, plus the operation of natural selection, so different selection factors in those different environments, can create two species out of one. And the fact that there are many, many ways to make a living and places to live and so on will lead to many, many opportunities for natural selection to fashion or to change and modify and sculpt species in different ways. So you'll get lots of different species. For Paley, why are there so many different species? He can refer to perhaps God's will. We might not really understand why, but God somehow delighted in producing many, many different kinds of species. What about groupishness? Why can we categorize species into groups based on similarity? Again, Darwin's going to say that the amount of time since the common ancestor is a key factor. Species with recent common ancestors are going to have a lot of similar characteristics, and so we will want to tend to classify them into a group. For Paley, again, reference perhaps to God's will, or perhaps God had a certain sort of body plan for a certain type of animal, and then maybe just made minor modifications. So there is, maybe there's the plan for a bird, a generalized bird, but then God perhaps made slight little modifications of that overall plan to produce the many bird species we see today. So we can group those species because God sort of just used the basic bird body plan, but then tweaked it a little bit in making all the separate species. What about extinction? Darwin's going to say environment changes too fast for natural selection to generate new adaptations. And that environment would include just physical changes on the planet or also the evolution of new species. For Paley, again, God's will. So perhaps at some time in the Christian worldview, perhaps the flood, right, eliminated many species, and that's why we see some in the fossil record that are not around today. So Darwin's revolutionary view of the natural world amounts to the idea that very simple living organisms like bacteria long ago on planet Earth evolved into the millions of different species we see today. So here we have a tree of life, and we're familiar with lots of animals and plants and things on planet Earth. And Darwin's argument is all these millions of species that currently inhabit the planet can trace their ancestry back to some common ancestor, the last universal common ancestor we can call Luca. And that living organism would have been the first living thing on Earth some 3.5 to 4 billion years ago, and it would be something like a bacteria type of cell, the simplest kind of cell that we know of. But from so simple a beginning, right, lots and lots of wonderful species have evolved. Now, how can we even sort of conceptualize that? How can we get our head around that? Well, one of the problems that Darwin understood and tried to remind people when they were having difficulty imagining this whole process is that 4 billion years is an incredibly long time, right? So if we just appreciate today that when living organisms reproduce, they can produce variation in their offspring. And if we now think about different selection factors in the environment favoring certain traits over others and changing organisms over time, 4 billion years of that process may indeed be enough to produce millions of species from one original life form.